So in this video, we are looking at writing equations in two variables. So an equation in two variables represents two quantities that change in relationship to one another. And a solution of an equation in two variables would be an ordered pair that makes the equation true. So for example, if we had an equation like this, y equals 2x. So this obviously has two variables here, and a solution would be an ordered pair. So for example, we could have this potential solution here, 3, 6. Remember that ordered pairs are always written x, comma, y. So in this case, we're saying that our x value would be 3 and our y value would be 6. So if we wanted to determine if this is a solution, if 3, 6 is a solution to this equation, y equals 2x, we can substitute those values. So 3 represents x, so we could substitute 3 for x, that would be 2 times 3, and we could substitute 6 for y. Now, if both of these sides are equal, 6 equals 2 times 3, which is 6, then this would be a solution. 3, 6 is a solution. Let's look at another example here. So we have the equation y equals 7x, and we want to tell whether the ordered pair 2, 21 is a solution of y equals 7x. So again, 2 is our x value and y, or 21 is our y value. So that would be 21 equals 7 times 2. And we know that 7 times 2 is equal to 14. These are not equal, so this ordered pair is not a solution to this equation. All right, now looking at another example. So an equation in two variables always has an independent variable and a dependent variable. So we'll write those out. Independent variable and dependent variable. Now, the variable representing the quantity that can change freely is what we call our independent variable. So, for example, let's think about, let's say you are going to buy some shirts at a store, right? So, there, for example, we could have an equation that would say the amount of money that you spend, we'll call that y, will be equal to the cost of the shirt multiplied by how many shirts you buy. So let's say each shirt is $10 and x will represent the number of shirts that you buy. So in this case, our independent variable, you have control over how many shirts you buy, right? That is our input variable or our independent variable. So you can choose how many shirts you buy, and that will influence how much you spend. So if you buy one shirt, you spend $10. If you buy two shirts, you would spend $20. 3 shirts, you would spend $30. So x here is our independent variable, and y is the dependent variable. So let's look at another example. The equation y equals 64 minus 8x represents the amount y of chemical remaining in a flask after you pour x cups. Identify the independent and dependent variables. How much of the chemical remains in the flask after you pour 5 cups? Okay, so we can tell, right, if this number here, y, is how much you have left, what you have control over is how much you're pouring out. That's x. Right? So x again would be our independent variable because that is going to influence y, the amount that you have left after pouring some out. So x here would be the independent variable and y would be the dependent. Now if we wanted to solve when we pour 5 cups out, then that would be y equals 64 minus 8 times 5. We know that 8 times 5 is 40, so y equals 64 minus 40, and that would leave us with y equals 24.